Hello, we're here for the August 2016 Geometry Regents exam solutions. So, number one, what we're looking to do is look at the parallel lines cut by a transversal situation. Sorry, wasn't really ready for that. Um, we're actually trying to find out if there's any parallel lines. And what I did for this problem was I kind of calculated the missing angle in each situation. So what I did was I used linear pair idea, right? The linear pair concept is this right here. Okay, if you have a line, total is 180, right? So if we have 112 here, we're going to do 180 minus 112 and get 68. All right, so you're looking at 68 degrees and 112s on this intersection. 78, well, L is not going to be parallel to M because that would have to be 78 or 68. I'm sorry. All right, what's 122? 180 minus 122, that's going to be 58. All right, so we've got 58s and 122 on N. And I already know what's going to happen here. 180 minus 68 is 112. All right, this one's good. So see these 68s and 112s, we're going to match up with L. Let's see. Okay, yeah, we can use alternate exterior angles. When those are equal, the lines are parallel. So it's lines L and P are the parallel ones, and that's the true statement. That's what we're looking for on number one. All right, number two, this one's a basic concept, not produce an image that's congruent. The only one that's going to change size is dilation. Yeah, dilation. A stretch would not be congruent, but I don't see that as a choice, so we want choice 2, dilation. All right, number 3, equal. Okay, we're going to, this is something we just covered recently. Equilateral triangle continuously rotated around one of its medians. All right, so what you have here, okay, all the sides are the same. It probably doesn't make any difference. And then the median's going to hit the midpoint right here. Now, if we rotate it around there, we are going to produce a cone because that's going to turn, that's that 3D shape that we're going to produce. Okay. That is going to turn into a circle, comes up to a single point. So, yes, we're looking at a cone. We can't possibly get a pyramid. Spheres, just not going to happen. That'd be if we rotated a circle. But, yeah, these two are not even close. That's only going to be if we rotated a circle. All right, there's a lot to this one. What I like to do with these problems is split up the diagram. So if you look, I've got this triangle, A to B to D. I've got a potential for this triangle, B to D to C. And then we've got a big triangle. And whatever you do, you cannot trust what the diagram looks like. Okay? We cannot trust that at all. There's been problems where they've misrepresented the problem, make the diagram look wrong. We got to pay attention to the numbers. So if angle DBC might not be the smallest angle, but what we're saying is that is 30 degrees. Follow the path. D to B to C, BDC, BDC. So that's 100. Okay, so I could use that. If that's 100, then this angle is 180 minus 100, if we need it. So that's going to be 80. Oh, here we go. That's 100 plus 30, and 180 minus 130, that's 50. Okay, so we got a 50 there. All right, we're getting someplace with this. And angle A is 50. There we go. We could solve this other one. If you do the math here, you're going to get 50 there, but we don't need it. What I did notice right here, okay, is that triangle ABC is isosceles because these two angles worked out to be in the same. So triangle ABC is isosceles. That's the one we wanted. All right. ABD is not scalene. Angle ABD, yeah. All of these are not going to work. Yeah. So we can eliminate the rest. It's definitely choice 2. All right. We want to go with a counterclockwise. That's this direction. We want to travel this way. Okay. That's actually the way we're supposed to travel unless they tell us otherwise. Now, so what does it mean to take a point and rotate it about the origin? Basically what we're saying is whatever this distance is has to continue, okay? So it's essentially saying, if I could do this perfectly, which I can't, it's essentially saying make a circle, right, around P, if we could, centered at the origin, and it's going to travel, if we rotate, P is going to travel around here, okay? Now, 90 degrees, this isn't going to quite cut it. If we go P to the origin, right, to B, that angle's not going to be anywhere near a 90-degree angle, okay? You want to make a 90-degree angle here. It looks like this was a reflection over the x-axis, so it's probably not B, okay? I do like A. That, to me, looks like the same distance away, and it looks like 90 degrees in the correct direction. This looks like 90 in the wrong direction. I couldn't tell you what that is. It's like 120-ish maybe, but again in the wrong direction. So we're going to have to go with A. That's got to be our best option. All right. The next one is kind of an old trig problem. Or we could just use for this course, what we like to say is we like to have the concept of something like this. If you have cosine of, say, I don't know, 70 degrees, right? We have learned in this course that it's the same value as sine of 20 degrees, okay? Basically, cofunctions are equal when their angles are complementary. So how are they saying that in this problem? Well, triangle ABC, where C is the right angle, okay? C is the right angle. And they're telling us cosine of A is the square root of 21 over 5. Now, really, if you know your trig functions, okay, cosine's telling you to go adjacent, which is this one, from A, all right? Now, this gets tricky. Compared to angle A, this is the adjacent side, you know, because we're saying adjacent leg. So square root of 21 would be there. The hypotenuse would have a 5 on it, okay? And in the old trig problems, we would solve for this and work it that way. But they really don't want that here. They want us to realize if angle C is a right angle, angle A and angle B are complementary. This is what all they want us to know here. So cosine of A is supposed to equal sine of B. So it's very simple. There really is no work involved in this other than this concept. So what's sine of B? Same as cosine of A, square root of 21 over 5. All right, but if we did this, you could see this, you know, using the diagram. Sine is opposite over hypotenuse. You are going to get square root of 21 over 5 doing the work this way. All right, so let's move on. Number 7. Let's see, quadrilateral. All right, they didn't tell us it's a parallelogram. They're saying what's not enough to prove it's a parallelogram. All right, this is one pair of opposite sides, parallel and congruent. That is enough. All it takes is one pair of opposite sides, parallel and congruent. We can guarantee it's a parallelogram. Both pairs of opposite sides congruent. That is enough. So you got to get rid of it because it's not enough. We want not enough. This is one pair of opposite sides, parallel and congruent. So that is enough. What is this one? A, B, C, D. Looks like, oh, here we go. This is the one. If you have these the same and these parallel, you could have a parallelogram. but you could also have an isosceles trapezoid, okay? So that's why it's not enough information. You've got two choices. You either have a parallelogram or you have an isosceles trapezoid, and that is not a parallelogram. So it could be choice 3. This is both pairs of opposite sides parallel. That's going to be enough. So nice problem, but not easy. Equilateral triangle has sides of 20 height. Okay, so they want you to sketch this. Anytime we can, please make a model. It makes the problem so much more reasonable. So what we're going to do is, since it's equilateral, all the sides are the same. That's 60 degrees. That could be useful. Maybe, maybe not. And what they want is this altitude. We'll call it A. Or height, actually H, yeah. They said height. So let's go H. Number of ways to do this. You can see it right now. We could use trig. We could even use Pythagorean theorem. I'm going to use Pythagorean theorem. To me, that's easier. If you draw an altitude from an isosceles triangle, you're going to cut this side in half, okay? So that's how I know that 20, cut in half is 10. All right, the whole thing's 20. So this section right here is 10. We have 20. We got H. I'm just going to use Pythagorean theorem. A lot easier. Okay, so I'll quick run through that. H squared is 300. All right. And square root of 300. That's got to be 17.3. Nothing else would even be close. So I'm going to use the calculator there. All right. Similar transformations. Okay, we got to prove that those are similar. 180-degree rotation would put C down here. Yeah, we've got to get C to what? F. That's got to be 90. It's got to be 90 degrees. Okay. So let's get rid of the 180s. I don't think that's going to work. The 90s will, but then the figure is going to get bigger. It shows right here, 3 to 6. You're not going to get that from a translation. Translation can't change the size, so get rid of that. Okay, it's got to be choice 4. It's the only thing, because dilation will double the size, right? Yeah, that one checks out. That's choice 4. Okay. Yeah. Three similar right triangle problem. Yeah, this one's pretty common. There's a few variations we can use on this. If this is going to be a right angle. Let's see, it didn't say it is, so we got to make it happen. All right. I'm seeing they want to know this. All right, usually they want to know CD, so that's not going to work. They want this one. All right, here's what they want. You see this triangle here, the small triangle? It's got a small leg and a hypotenuse. Now the big triangle has a small leg and a hypotenuse. See, that's 10. And these are similar right triangles, okay? These angles are the same, so you can see that. So here's our proportion. Hypotenuse, or actually, let's go small leg first. Small leg on this one to small leg on that one should be the same as the hypotenuse of the small triangle to the hypotenuse of the big. So corresponding sides of similar triangles are proportional. That's what we're using. So x squared is 40, square root. Oh, great. None of those are my choices. Go figure. All right, so they're kind of forcing us to know how to do this. Simplify square roots. You can split square roots using multiply or divide, just no add or subtract. Square root of 4 is in fact 2, so we get 2 square roots of 10, and that's choice 2. All right, almost done here. CD is so let's start with point, right, AB. Now, perpendicular bisector is all the points that are the same distance from points A and B. It's the definition of it. So we got to know that definition. It's a collection of all points that are equidistant from both. So back to this, yeah. The perpendicular bisector, we've got the collection of all points that are equidistant from the two given points, A and B. Now, so it gives us a few things. Let's see, this point is E, so AE is the same as EB. Now, which segments do not have to be congruent? So we got to eliminate these, because these do. Okay, now C and D, they can be anywhere. So C could actually be down here more. That's not going to affect anything. All right, so C can be as close to E as D is, or further, doesn't make any difference. It's looking to me like this is probably the one that doesn't have to be true. All right, let's talk about these other ones. A to D has to be the same as D to B. Okay, because of this definition right here. It's all the points that are the same distance from both A and B. Same thing here, okay? A to C could be a different distance than A to D, but has to be the same as C to B. So yeah, we got it right. That's the choice we want. All right, 12 is, okay, this is a little bit tricky. This is a similar triangles problem, and we're going to need corresponding sides proportional. But usually, oops, what happened? Okay, touch screen there. So usually what happens is these would be lined up nicely, you know, so that the corresponding sides would be easy to match up. But they're not. What they did in this problem was they flipped basically that triangle right there. So we're going to have to adjust it, okay? Here's how I know that they flipped that, because H, angle H, we're saying is congruent to RDO. Okay, so let's just imagine for a minute we flip this back. That still would be R. Okay, there it is. We do have these are congruent because of reflexive property. Angle H, though, is congruent to angle D. Now, if we put D here, so what I did was I flipped basically this so that they're lined up a little nicer. But we've got to be really careful now getting this correct. RD is 4, RO is 6, OH is 4. So they're basically saying that's 10. If that's X, this is supposed to be X plus 4. All right, so let's put these numbers back over here. So HR is 10, CR is X plus 4, OR, now be careful, we flip this, so it's 6, and RD is 4. All right, once we set it up like this, it's very easy to get our proportional corresponding sides. So I'm going to start right here. 10 corresponds to 4, so we'll make that one of the fractions. X plus 4 corresponds to 6, and now we'll run the cross products. And let's see, 4x plus 16. Of course, there's probably better algebraic ways of doing this, but we'll just go this way. And divide by 4. So x is 11. Now, be careful. Is that actually what they wanted? They wanted CD. All right, x was CD, so we do have 11. And that's it for this session. Thanks much.